All right, ladies and gentlemen, I am calling this video just the epicenter problem. We're going to see these different types of videos or different types of problems regarding the epicenter of an earthquake. So I wanted to go ahead and put together a video that represents it. The epicenter of an earthquake is simply the point on Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs, plural, are needed in 3 different places to locate an earthquake's epicenter. Use the seismograph readings from the following locations to find the epicenter of an earthquake. So simply, what is a seismograph? A seismograph is just simply a way to determine how far from the start of an earthquake, all right, does the earthquake kind of rumble on out, right? So we don't have too many in Florida, but in like San Francisco, right? If there's an earthquake in the heart of San Francisco, a seismograph will help us realize how far from the center of San Francisco does the earthquake's effects hit? How hard are they going to hit, and how far are they going to feel those effects of the earthquake from a particular center point? So let's take a look here real quick and just see how this relates to what we know about circles. So in this first example, all right, we had an earthquake reading, all right, from point A that was going to be at -2 and positive 2.5, so somewhere roughly in there. That was A. And it said that the epicenter went 7 miles from that point. All right, so what I'm going to do is I'm going to go ahead and bring out a tool. I'm going to find a compass here. And what I want to do is I want to create a circle that is going to represent 7 in our radius, right? So if here's my center, I felt it 7 miles out. So I want to find out what this radius would look like. So we are at 1, 2, 3, 4, 5, 6, and 7, right? Whoops, and 7, right about here. All right, so there's about our mark at 7. And so if I just make a circle and continue around, all right, the center was at -2 2/5, or 2/2, and we end up having a circle with a radius of 7. Well, let's kind of continue the same concept here. For the other epicenter, we had one at 4, 6. So at 1, 2, 3, and 4, and 1, 2, 3, 4, 5, and 6. So we had one right here. And this had a radius also of 4. So this one had a radius of 4. So let's try to sit there and get it to where we have a radius of 4. So there would be 4. And let me just try to get it over a little bit. There we go. All right, so there is a radius of 4. So let's go ahead and make our circle from 4, 6 with a radius of 4. All right, and last but not least, we want to go ahead and find one last one at +3 and -2.5. So 1, 2, 3, and 2.5, right about there. And this had a radius of 5. So I need to move around I'm going to put it over here so it's easier to count. So we're down here, so I need to go 1, 2, 3, 4, and 5. So I'm going to need to bring it up just one more to about right there. And then I make my circle. And bada boom. So the question is, right? The question is find the epicenter of the actual earthquake. So what we saw here, let me kind of just recap this for a sec. So what these circles all represent. We took a reading at point A, and we saw that its effects around point A were a radius of 7 miles around this area. And then we took a reading here at 4,6, and its effects were right around here. And then we took a reading at 3, -2.5, and it felt its effects 5 miles away, so it was all around here. And so the question was, where did the actual earthquake begin? Well, what do you think? Where would the connection between what we know about circles and what we know about this problem in general, where would we think to find it? Well, hopefully we realize that it's at the intersection of all 3 circles. So that's where we're going to end up finding our epicenter. It's actually going to be at the intersection of all 3 circles. And so in this case, it's roughly at about 1, 2, 3, 4, 5, and 2. So we're going to roughly have it at about 5, 2.